Second idea about networking, about how the internet works. That's kind of interesting. Interesting design decision in the internet. The systems, the machines that run the internet are dumb. They're pretty dumb. There's a deliberate design decision here, which is that routers have very little knowledge about the global state of the internet. For instance, they might not know all the connections that are going through them. They might have no memory of that. They don't try to remember that. They don't try to know, oh, there's a connection from someone over there to someone over there currently going through me, and I got to reserve space for that or something. No, they don't do any of that. That's how the telephone system works. In the telephone system, there's a bunch of switches, and each switch knows all of the ongoing phone calls and who's the originator and who's the recipient. But that's not how the internet works. The analogy to think of for the internet is like the postal system, like postal mail. Okay? So in postal mail, you take a mail and you drop it in the mailbox, and it gets passed on to a post office, and maybe goes to a sorting location, and then it gets passed to another location, and then finally on to the destination. Well, there's no memory that I have sent a bill to this address, on the 1st of March first of every month for the past year, and so expect one next month or anything like that. It's just each envelope is handled on its own, and it's kind of in isolation. Okay, so that's how the internet works, is that each message, we call it a packet, each packet is self-contained. The routers will look at a single packet with no memory of the past packets, and they'll look at some data in that packet alone with no additional context and decide where to send it on, where is the next place to send it on to. They might not know how to get all the way to the ultimate destination, they just know how to get one step closer. And the philosophy here is if you want to do something smart, if you want to do sophisticated management of a connection and adjusting the amount of data you send or in response to the drop rate or the latency or something like that, you don't build that into the routers. You build that into the endpoints. And this is a kind of a scalability design principle, that the routers are kept as simple as possible, and that way they can scale to handle tons and tons and tons and tons of traffic because they're super simple. And then the smarts is on each individual endpoint. It also provides flexibility. It means that it's easy to adapt, to introduce new features, because those just have to go into the application or in the server. You don't have to upgrade all the routers in the middle of the internet. So that's enabled really rapid innovation. Okay? So what this gets you is kind of simplicity. There's some robustness. There's some performance at the cost of making the endpoints more complex. Now, this is a simplified view of life. In practice, the internet today has all sorts of hacks that violate this here and there, but this is a good first approximation. So think of this as like your Chem 1A lecture where they tell you how an atom works, and they're sort of lying, but they're basically, it's a good first cut at what's going on. And then there's always a little bit more complicated.